2013 question 2. Stephen's making design with posts and rails. Here's number of posts, number of rails. You might like to fill in another couple places just to make sure you can see that the pattern there. Okay, first thing we do when we're looking for rules is to have a look at the differences between the terms. First difference there is 4, 4, 4, 4. Now when that first difference is the same, then that implies it's a linear pattern and a linear rule would be used. The 4 tells us lots of things. If we were to graph this information, this on the x-axis and this on the y, then the gradient would be 4. It also tells us what we need to times by for the rule. We need to times these numbers by 4 and then make an adjustment. So if we check this one, 2 4s are 8, we'd need to minus 4 to get 4. 3 4s are 12, minus 4 gives me 8. 4 4s are 16, minus 4 gives me 12. So I can see that for P posts, I'd have to times by 4, subtract 4, and that would give me the number of rails. The other way to write this would be 4P minus 4. Either of those is fine. Right, and of course we have to draw a graph. So for 2 posts, this will be posts here, and this will be rails. Let's set ourselves up. For 2 posts we need 4 rails. For 3 it's 8. We needed to check the scale here, of course. 2, 4, 6, 8, 10. It's going up in 2s. The next one would be 12, 16, 20, 24, 28, 32, 36. Now we don't join. It's a practical pattern. And for a practical pattern, we don't join the dots. Right, on to the next one. Now this is a harder question. Design decides to model the designs using matchsticks. She completes one of each design, so one of those, one of those, one of those, and so on, up until she has P posts in her last one. So this has 2 posts, 3 posts, 4 posts, and she wants to keep going up to a general number, and she's going to make one of each as she goes along. Give the rule for the total number of rails she would use. So I feel we need a table. This would be the total number of rails here, and this would be the number of posts in the last design she makes. So if she just makes the first design, one of those, it has 2 posts and 4 rails. If she makes the first one and then the next one with 3 posts in it, she'd actually need 4, 8, 12 rails altogether to make one design of that and one of that. She's laying out matchsticks along the floor. Now if she were to make the first, the second and the third, laying them out with matchsticks, the number of matchsticks she'd need to make the rails would be 4, 8, 12, 16, 20, 24 rails altogether. We might try one more if she was to do design 2 and 3 and 4 and 5. Oh, this is design 1, 2, 3 and 4, but with 2 posts, 3 posts, 4 posts and 5 posts. Then let's have a look at the pattern. We're going up at 8, 12. The next one we need to add 16 to that to give me 40. Looking for a rule, I can see the first difference is not the same, so it's not linear. We'll have a look at the second difference, and this time, thankfully, the second difference is the same. So that implies a quadratic rule with an x squared term, something to do with that number squared in the x column there. Okay, so now we need to jump over to our calculator and we need to put some numbers in here. So if we start by putting those numbers in, should be enough. 3 for a quadratic, we'll go to hover over F1, graph, calc, and this time we're choosing x squared because we think it's quadratic. There's the general form of the equation, we could copy that down. Y equals ax squared plus bx plus c while we're thinking. Now I can see that a takes the value of 2, b takes the value of negative 2, and actually c is 0, which would be great. Now if you can use the letters that they've hinted at up here, that would be even better. So if we use t for the total, it's going to be 2 times, our x here is the number of posts, p. 2 times p squared minus 2 times p. Now a way we could check that is to go into the table menu, type in this formula, 2 times x squared, this one here, minus 2 times, oops, not that one, 2 times x, and that disappeared. Let's try again, 2 times x squared minus 2 times x, and enter it. We'll set that and we'll start from 2, and going up to 5 is fine in steps of 1. And we could just check that we do get those same numbers so I know that my rule is right. You could also check it in menu run and just try putting some of those numbers into that formula. Right, Graham is using a different pattern. Here's his pattern. Give a rule for the number of rails needed when he has p posts. So once again, there are 2 posts there, 3 posts there. You need a small table. 2 posts have 1, 2, 3 rails. 3 posts have 1, 2, 3, 4, 5, 6 rails. And 4 posts would need would have 9 rails. P for posts, R for rails. We need a rule. Looking at the difference between them, clearly it's going up in 3. So that tells me for a general P, I'm going to have to go times 3 and make an adjustment. So let's think about that. 2 times 3 is 6. I'd have to minus 3. 3 times 3 is 9. And then we'd have to minus 3. And we'll check one more. 4 times 3 is 12. Minus 3 is 9. So I need to take P, times it by 3, subtract 3 to get the number of rails. And writing that in algebra, we can write it as 3p minus 3. Use the rule to find the number of rails Graham needs when he has 20 posts. So the number of rails will equal 3 times 20 minus 3. That's 60 minus 3, 57 rails. Right, in the last part of this question, between Graham's graph and Stephen's graph, once again 3 comparisons would be good. We'll try and think of 4. We could mention that both graphs have discrete data, slash points, and depict practical patterns so are not joined with a line. We could talk about the gradient of the line. I realise that there are no lines drawn, but still implied between the 2 rules are 2 gradients. And we could just remind ourselves, this is Graham's one, so Graham was 3p minus 3. That was Graham, which means Stephen's was the 4p minus 4. So we need to comment on the gradient here. Stephen's is going up in steps of 4 each time per extra post. Graham's is only 3. Stephen's graph goes up by 4 with each extra post. Graham's goes up by 3, and to just show off a little bit of maths, we could say gradient for Stephen would be 4, and for Graham the gradient would be 3. Right? We need to comment on something else. Now the other thing we can comment on is perhaps the first term. We could talk about the y-intercept if we were to draw a line, but it doesn't really have a practical meaning in this situation. So it might be better off discussing where they start at. Both graphs begin with 2 posts. However, Stephen needs, how many rails does he need for 2? 2, 4, 8, that's 4. It's 4 for design 1, and Graham needs 3 for design 1. This problem was a little bit harder because we were talking about posts and not actually the design number. So you have a look at that.